So in this video, we're going to be learning about runnables in LangChain. Runnables in LangChain. Now, runnables are the art of LangChain. Runnables are the art of LangChain. Every important thing in LangChain is a runnable. Runnables are considered the building blocks of LangChain. And in this video, we are going to be learning about runnables. So let me get my pen and let us start doing some whiteboard stuff. So runnables in LangChain. That's what we're going to be discussing. Now, what are runnables in LangChain? Runnables are basically units of work in LangChain. Yeah, a runnable is a unit of work in LangChain. So let's say this is a runnable, and it can be anything. Different components in LangChain implement the runnable interface, prompt templates, chat models, retrievers, output parsers, almost like I said, document loaders. Almost everything in LangChain implements the runnable interface. And like I said, a runnable represents a unit of work in LangChain. And a runnable is basically something that takes an input in LangChain and generates an output. So it takes an input and generates an output. Now this looks like a G. I'm just trying to like do something like a cycle, like work took place. So yeah, this is a runnable. Runnable in LangChain. So they're basically units of work in LangChain. They're standard building blocks of LangChain, and their basic attribute is that they take an input, they process it, and generate an output. However, the standard LangChain, standard runnable interface in LangChain has three main attributes. The standard runnable interface in LangChain has three main attributes, and the first is that it can be invoked. And what this basically means is that you can pass in an input, a single input, and generate an output. That's what invoke basically means. You can take a single input and generate a single output. The second attribute is that it can be batched. This means that it can take multiple inputs and generate corresponding multiple outputs. So you can pass more than one input into it, and it can generate corresponding multiple outputs. So if you pass 3 inputs, it's going to generate 3 outputs for those inputs. That's the second thing. Number 3 is that it can be streamed. The output can be streamed. So if it's a synchronous process or it's a long-running process that is occurring asynchronously and the output is coming gradually, probably coming in chunks, you can stream the outputs. And you can iterate over it and be able to process the output or display them or pass them in chunks. So these are basically the attributes of runnables in LangChain. Those are the main attributes. This is the runnable interface, the main attribute of the runnable interface. But why runnables in the first place? Why runnables? Why is LangChain so high on runnables? The main thing that makes Runnable special is this. Composability. Runnables can be composed together. It's magical. It's lovely. You can take one runnable, let's say runnable 1, and pipe it into another runnable. And the result of that one, you pipe it into another runnable. They can be composed. And they can be composed in parallel, and they can be composed in sequence. So that is the main benefit, the main selling point, rather, for runnables. The output of one runnable, let's say we have a runnable here. It takes an input. The output of that runnable can become the input of the next runnable in a chain. Then the output of that runnable also can be the input of a following runnable. Runnable 1, runnable 2, runnable 3. And it can go on and on like that, even though you don't want to make super long chains. So you can connect a, let's say, a prompt template to a model, that's an LLM. So the model processes the prompt, and the result of the model goes into a parser, an output parser that can pass it in JSON, can pass it in XML, can pass it as a simple string, anything. So you can create chains, you can orchestrate chains of workflows with Runnables. That is their ultimate selling point. That's their ultimate selling point. So that's Runnables. And one thing you can also do with Runnables is that you can convert a function. You can convert a function, a Python function, to a runnable. Let me pick a different color to probably illustrate this. So you can convert the Python function to a runnable. For example, using the runnable lambda class. Don't worry, we're going to see it in the demos. Using the runnable lambda class, you can convert a pure Python function to a runnable. So you're not just stuck with the runnables that come with LangChain out of the box. You can actually build your own runnables. You can also run runnables in sequence using runnable sequence. Runnable sequence. You can build a sequence of runnables. For example, this entire process is a sequence of runnables. And later on, we'll be seeing something called the LCEL, which is a LangChain Expression Language that just automatically creates a chain for you. But you can do it manually. You can create chains manually using runnable sequence. And you can also create parallel. You can also run runnables in parallel using runnable parallel. Runnable parallel. We're also going to be seeing a sneak peek of that in the demos. So this is what makes Runnables special. They can be composed, and using that composability, they can run as a chain, and you can also run them in parallel. So that's what Runnables are in LangChain. And now let us write some code. Let us do a demo. So now that we understand what Runnables are all about, let us write some code. And we are going to start by building a simple chain of Runnables, basically with a prompt template, model, and parser. Then we're going to see how we can add another runnable and convert a function to a runnable. And ultimately, we'll see how we can actually take two different chains, and join them together. So let us go ahead. Let me close out of this first. No, I'm not trying to do that. Okay, good. We'll close out of that. And the first thing we're going to do is to create our virtual environment. So I'm going to pull up my VS Code command palette so that I can get that quickly done. So create a Python virtual environment. That's good. VENV is showing up here. So yeah, we're good to go. Now, if I pull up my command line, let me close this. Let me just close out on this. And pull up the command line once again. Yeah, so we have VENV. We have .venv here. Okay, yeah, good. So get this down. And I'm in my command line. The first thing we're going to do is to import the dependencies. And we're going to be needing two specific dependencies, LangChain Core and LangChain OpenAI. LangChain Core because that's where all our main core components are, our output parsers and our prompt templates. We're also going to be using LangChain OpenAI to do our LLM operations. So let's just get those in. Say pip install LangChain Core, LangChain OpenAI. Hit enter and watch that go. This shouldn't take so much. But while it is running, let us create our file. Our Python file, which will be called working with Runnables.py. Working with Runnables.py. And if we look over to our command line, is done. So we can close out of this now. That's good. Now we can start working with Runnables. And like I said, we're going to start with a simple set of Runnables in a sequence chain. So first, let us get in a prompt. Our prompt templates, say LangChain core.prompts. Import chat prompt templates. Get chat prompt template in. That's good. The next thing I'm going to bring in is the LangChain OpenAI package. So from LangChain OpenAI, import chat OpenAI. For chat OpenAI, so that will take care of our model. And for our output parser, we go LangChain core also dot output parsers, import, and we're going to be using the string output parser. The string output parser. So we've gotten in our chat prompt templates, we've got our chat OpenAI for our model and our string output parser. This is the simple chain we're going to be building. Prompt, model, parser. That's the chain we're going to build. So first, let us set up our model so that we know that we have that in place. Say chat OpenAI. And we set the model to, let's just use a simple, rather a fast model. Let's say GPT 4.0 mini. Yeah. GPT-4.0 mini. So use GPT 4.0 mini, and that should be good. That should be good. Now, like I said, the first thing we're going to do is create a simple chain. Components like prompts, models, and output parsers, they already implement the runnable interface, so they are runnables out of the box. They are runnables out of the box. So what we want to see is how we can compose them into a sequence, a runnable sequence. And what we want to do is I want to get a template. We want to get a prompt template to generate a prompt value. We will then pipe that prompt value into a model. Then the model is going to process the prompt. It's then going to send the result of that prompt, the response from that prompt, into a string output parser that will just get us our result as a string. We don't need all those AI response message that comes back. It will just get us a string. So that's the chain we're going to be building. And let's get started. First, we're going to build our prompt. So I'm going to say prompt equals chat prompt template from template. Just going to create a simple prompt. And our prompt is going to say, write a short, concise sentence about, then we'll just put a dynamic variable there and say topic. So write a short, concise sentence about topic. Yeah, that's what our prompt is going to say. So we just want to give you the topic, and it's just give us a brief summary of that topic. Let's say, okay, RAG. Oh, RAG is this. Context window is this, MCP is this. So that's just basically definition stuff. So the next thing is our output parser. We already have our model set up. So let's just set up our output parser. So I'm going to say output parser equals, and we'll just set that to an instance of our string output parser, which I'm just going to copy and paste here and initialize. So output parser, string output parser. Now, to create a simple chain, we're going to be using something known as LCEL, LangChain Expression Language. And what it does is that it gives us this pipe operator, that we can use to create a chain with our runnables. We can use to create a chain of our runnables, in which every component is going to appear in the order to which they are actually involved in the process. So let's say creating a simple chain. That's the first thing we'll do. And here our simple chain is going to be our prompt. We then use the pipe operator, which is LCEL, LangChain Expression Language. The pipe operator, and we'll say pipe the output of this prompt into this model. Good. Then take the result of this model and pipe it into our output parser. Awesome. That's our simple chain. Pipe it into our output parser. And that's how that works. We're good. Everything looks fine. Awesome. Now, this is one way to do it. You can also use a pipe method. There's this pipe. You can use a pipe method from Runnable sequence, but for now, we're just going to be going with the LCEL format. So, simple chain, we create that, and we can then invoke it. Yeah, we can invoke it. Remember invoke? Yeah. Invoke takes a value. It takes an input and it processes it to take an output. And why can we call invoke on our simple chain? It's because the result of composing runnables is also another runnable. Yeah, the result of composing runnables is also another runnable. So the fact that we compose a prompt with a model, with an output parser, it returns a runnable also. So in as much as we can always invoke a prompt, invoke a model, and invoke an output parser, we can also invoke the resulting chain that comes out of it. So You can say result equals simple chain dot invoke. Simple chain dot invoke. And we get to invoke that with our dictionary of values. Our dictionary of values. Now, this dictionary of values will go to the very first item in the chain. That's what it goes to. It goes to the very first item in the chain, which is our prompt in this case. So we pass the topic. For this topic, we'll just enter something simple like functional programming. Yeah, it's kind of funny that I called functional programming simple. But yeah, let's just say, tell us something about functional programming. So tell us something about functional programming. Write a short, concise sentence about functional programming. So we invoke that, and we can simply print the results. Print the result. And that should give us the result of our chain. We have 3 runnables working together now, and we're invoking them as a chain with values. Let's see the result when we print this. Let me pull up my command line. Let's clear that. And now we're going to run Python working with Runnables. Now, before you run this, we're using OpenAI as our model. So you have to make sure that your OpenAI API key is currently active. If you want to add it to your current terminal session, you can do export OpenAI API _key and set it to the value of your key, whatever that is. Or make sure if you want it persistent, you can add it as an environment variable in your bash.rc file, your zshrc file, or or in Windows, just add it as an environment variable the Windows way. So, and now that I'm talking about it, I hope I've added mine. But I won't be able to know that until I run this. So I hope I've added mine. So Python working with Runnables. Let's hit enter. Some latency there because we are communicating with our model. I hope. Yeah. I don't have my API key. I don't have my API key in place. So what's going to happen now is that I'm going to add my API key off camera, then come back once I've added it. So now I've added my key. Sorry about that. I've added my OpenAI API key. And now we can rerun this command. So Python working with Runnables. Let's hit enter. And this should tell us, should give us our result. Just a string. It gives us our result, and it's a string. So it says functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state or mutable data. Yeah, functional programming. We set up our prompt template that it should tell us something about functional programming. It passed through our model. Our model processed it. We returned an AI message, and that AI message has been stripped clean by our output parser to give us just the string response. So that's wonderful. That's amazing. We have that working, and it looks good. Now, the next thing we're going to do, the next demo we're going to be doing, is to see how we can add another runnable to this chain. Yeah, so we have this chain. What if we want to tack on another runnable just at the end of the chain? Let's see how we can do that. So I'm going to come down here. Let's close out of this for now. Coming down here, and I'm going to just say demo 2, which is extending the chain. The chain with another runnable. So extending the chain with another runnable. So to do that, I'm going to create another variable called combined chain. Then I want to combine my simple chain with another runnable. Not with another chain, just with another runnable. So I'm going to say simple chain. So give me my simple chain, which is a runnable in itself, which is cool. And I'm going to say pipe, which is the LCEL format, just pipe it. And I'm going to create a new runnable inline. Using a lambda function. So I'm going to say lambda. And lambda give me the chain output. So the lambda function will take as its input argument the result of this chain. The result that is coming from this chain. It's going to take it as its argument. And all I want to do is take the output from that chain, and just tack on a string. Yeah, that's just a simple thing I want to do. I just want to tack on a string. Probably don't even need a full stop. And say, oh, wow, that's cool. Oh, wow, that's cool. Yeah, I just want to tack on that. So it will tell me the fact. Then after that, I just want to say, oh, wow, that's cool. So I create that using a Lambda function inline, surrounded by brackets. And one thing LCEL does is that it would automatically convert it to a runnable. To automatically convert it to a runnable. If I were using the pipe function, I would need to specify a runnable lambda. And a runnable lambda inside, then pass in the function. But yeah, we don't need to do that here. The LCEL syntax is just going to convert this inline into a runnable. But we're going to see how to convert a regular function to a runnable later using that runnable lambda stuff that we just saw. So yeah, what we want to do here is just take the chain output, that's the output from this simple chain, and just tack on, oh wow, that's cool. We just want to do that. So I'm going to save this. And then we can take our combined chain and run it. We can run it. Your combined chain is also a runnable. The result of tacking on runnables with runnables will still give you a runnable. So we're going to invoke that with a prompt. So let me just say, to just arrange things properly, I'll say combined topic. So that's the topic for the combined chain. So for the combined chain, I want you to tell me something about the topic Model Context Protocol. MCP, one of the hottest stuff in AI right now, at least at the time of recording this video. So combined topic MCP, Model Context Protocol. So I'm going to say combined chain results. Combined chain result equals combined chain dot invoke. And I'm going to pass it that same topic parameter because that's still expected by this simple chain, because that's what is going to be processed and sent into this. And the topic will be my combined topic. That's the topic for my combined chain. So combined topic. So that's good. Now we can go ahead and print the results. To print the results, I'm going to say print f string. Let's have some stuff here to demarcate. Say combined chain result or output. 1, 2, 3. Then here we can simply print the output of the combined chain. So combined chain result. Just get that and print it here. So print it here, and I'm just going to put another set of dashes under that. Just a dash and give me 45 of them. Okay. So we took our simple chain, we combined it with another runnable, but we created a runnable inline using a lambda function, and LCEL automatically converts it into a runnable lambda. Then what it basically does is that it takes the output from this chain and it tacks on, oh wow, that's cool. Like, oh man, that concept is so cool. So it just does that and it gives us the result. So I'm going to print that out. Or rather, we're going to process that. So let us bring up the command line. Say clear. Run this once again. Let's wait. It gives us the first stuff for the functional programming. Then we get our combined chain output. Combined chain output. It says the Model Context Protocol is a framework for managing and sharing contextual information across different machine learning models to enhance collaboration and performance. And we have our other runnable that says, oh wow, that's cool. That's really cool. So how amazing is that? We've been able to take our simple chain and we tagged on a new runnable at the end. Awesome. Now this runnable was created inline. Let us see how we can take an actual function, pure Python function, or just a Python function, and use it as a runnable, convert it to a runnable. Let's see that. Let's see how we can convert it to a runnable and also use it with our chain. So that will take us into the third demo. Demo 3. Converting a function into a runnable. Yeah, converting a function into a runnable. Let's capitalize. Okay. So converting a function into a runnable. Now, for the demo here, what I'm going to be doing is this. I'm just going to take the simple chain, the result that comes out, then I'll create a runnable that will take that result and just tell me the length of the string. You just tell me the length of the string that comes out. So First, we will create a function, create a Python function, and let's just give that the name get text length. Get text length. Okay. So create a simple Python function. It's going to take in the text as a string, and also return no, it doesn't return a string. It returns int. Yeah, returns int. So yeah. And what it's simply going to return is the length of the text. Yeah, it's going to return the length of the text. So this is our Python function. This is our Python function, but it's not a runnable yet. We want to convert it to a runnable so that we can add it to our chain. So now what do we do? We come down here and say length runnable equals. Then we need to call runnable lambda. We need to call runnable lambda to convert this into a runnable. Now to do that, first we need to import runnable lambda itself. So I'm going to come up here and say from LangChain core runnables import runnable lambda. So this takes a lambda function, or it takes a function basically, and just converts it to a runnable. So get runnable lambda. Then here we're going to call runnable lambda. No, not combine text result. I'm going to copy runnable lambda and use it down here. And we simply pass it our function. We'll pass our function, which is get text length. Pass our function. And this length runnable variable automatically becomes a runnable. It automatically becomes a runnable. It is a runnable and we can use it in our chain. So to use it, I'm going to say length chain equals. So I'm going to say LangChain equals simple chain. Then I'm going to pipe that to our length runnable. Yeah. Pipe that to our length runnable. Good. So this is cool. Now we have a new chain, which gives us back the length. Now let us test this out. We're going to say length topic. So let's give it a different topic. Which topic do we give it this time? Let's say retrieval augmented generation. And I definitely should put that in quotes. Oh yeah. So retrieval augmented generation, that's the topic we're going to give it. RAG. So we're now then going to say length results equals length chain dot invoke. Length chain dot invoke. Then we pass it the topic. That topic is going to be our length topic. Our length topic. So this is going to return to us number of characters in whatever result comes out. So let us print. Let's say print f. I'll say function converted to runnable. That is what we are running now. To runnable. Function converted to runnable dash dash dash. Then let's just print the result. So we say print length. Sorry, what am I doing there? Length GTH, and that is going to be length result. So it's just going to return to us number of characters in whatever came out of the invoked chain. So print, we'll say just give us 45 dashes under here just to demarcate stuff. Okay, so print length result. Now this will be a bit difficult for us to really verify because internally the whole invocation will be done for the simple chain. Then the result will come. We won't be able to see the result, but we'll be able to see the number of characters. But later on, I'm going to show you how you can embed the result just with a smart prompting, with smart prompting rather. Just with smart prompting, we'll see how we can embed the result from a point in the chain into the final result. So yeah, let us say length. Oh, sorry, save that. And now, if I go back and bring up my command line, it's clear. Now let us run this. Python working with Runnables. and our results start flowing. We have the one for functional programming, the one for combined chain, and yeah, the function converted to a runnable, what the runnable does is just to give us the length of characters, give us 176. Yeah, from the result that was returned, it counted it and it was 176 characters, and I believe that includes white spaces also. So yeah, now we have been able to take a function, we'll take a Python function and convert it to a runnable. How awesome is that? How awesome is that? Now let us do something a little more complex. This time, we're going to be, I keep pressing this guy. Okay, this time in this final demo, we want to combine two chains. Yeah, two chains. We want to combine two different chains. We're going to take our simple chain and we're going to combine it with another chain. And that is going to be a bit tricky. So let's just say, yeah, combining two chains. Okay. So we already have our simple chain. So let us build the second chain. Let's build our second chain. So first I'm going to create a prompt template for the chain. And what this chain is going to do, because this is quite important. What this chain is going to do is that concise statement that we want to be written from the first chain, we want it to fact check it. So it's a fact checking chain. We want it to just fact check that particular statement and tell us how true it is. So let's see what we get. So first I'm going to create the fact checking prompt. So it's a fact checking prompt. Then I'll set that equal to chat prompt template. Then here I'm going to use from messages, because remember what I said about the prompting stuff the other time, some smart prompting? I know that the fact itself is going to be embedded in the chain. The final output is going to be the reason why it thinks the fact is correct or not. But I want to get the fact also. So we're going to add a system message. And what the system message is going to say is start by quoting the statement, then give the reason. Start by quoting the statement, then give the reason. So it's going to know that, oh yeah, that statement I'm trying to fact check, I should first state it, that's in the final answer, which will be the final output of the chain. I should first state it before then giving the reason why it is correct or incorrect. So that's what our system prompt will help us do, to make us to make sure that what came out from the first chain, which is a simple chain, is actually part of our final answer. Now we can have our user prompt, which will definitely instruct the fact to be checked, which is how correct is this statement? That's the statement coming from the first chain. So we give a statement, meaning that what is coming from the first chain has to be sent into this next chain as a statement value, as a statement variable. So let's just have that at the back of our mind. So we have our fact checking statement. Now let us create our fact checking chain. Or let me just say, should we call it fact checking chain, or let's just say checker chain? Because I want to call the final chain fact checking chain, actually. So let's say checker chain. So checker chain will be fact checking prompt. To made up our fact checking prompt, pipe it into our model, because the model is also going to do the actual fact checking. And also we need our output parser to also help us to make sure that the final output is a simple string. So this is our checker chain. So we have that together. So now how do we combine the first chain with the second chain? The first chain, we need to get its result and get it as an input into this checker chain. We need to get its result and get it as an input into this checker chain, and it needs to go in as a dictionary. So what we're going to do is that we're going to create a runnable parallel, because runnable parallel can be created with dictionaries. The keys are the output, the name you want to give the output, and the values are the runnables that are going to generate that output. So I'm going to say runnable parallel with chain result. Yeah, that's a very long variable name. runnable parallel with chain result. And I'm going to set that to first. This expects the variable statement. It expects the variable statement. So the best thing to do is to give this key statement. And which chain is going to produce that particular result? Which chain is going to provide that particular statement? It is the simple chain. It is the simple chain. So it provides that and sends the result into this. This is how a runnable parallel is created. This is a short form of creating a runnable parallel instead of calling runnable parallel. As if you want to use LCEL, this is how you just create a runnable parallel. LCEL is going to recognize this and automatically create it as a runnable parallel. But if you want to use the pipe function, you need to wrap this with the runnable parallel class. But yeah, let's just leave that aside. So yeah, so we have this runnable parallel with chain result. Now we can create our fact checking chain. A fact checking chain. And our fact checking chain is going to be our runnable parallel with chain result, which is what is coming from the first chain, piped to our checker chain. Piped into our checker chain. So our runnable parallel with chain result packed into our checker chain. That is awesome. So now let us run this chain. So what do we do? Let's get a topic. So let's get a topic. I'm going to call this dual chain topic. Dual chain topic, and the topic is going to be prompt engineering. Prompt engineering. So dual chain topic, prompt engineering. Then I'm going to say dual chain results. And that will be my fact checking chain. I'm going to get my fact checking chain. I'm going to invoke it with a topic. And that topic is going to be my dual chain topic. Dual chain topic. So we want to generate a simple, concise statement about prompt engineering. Then we want our checker chain to fact check that. We want it to fact check that. So at the end of the day, let us print results. So I'm going to say print f string, let's say complex chain result. Complex chain results. And come here. We then print out the result itself, which is dual chain result. Print out dual chain result. Then, as it is now customary, we had some dashes under that. Oh my. That was a lot, right? Yeah. The world of runnables. But these stuff are actually quite simple. Actually quite simple. By the way, if you want to have a deep dive on Runnables, check out langcast.com. As you can see, langcast.com is on the top of this video. Check out langcast.com. That's your home for the best LangChain tutorials, and also not just LangChain tutorials, AI engineering in general. So yeah, if you want to have a deeper dive into all this, because this is already some level of deep dive. Want to have a deeper dive, check out langcast.com. If you see a coming soon page, it's still us, so you can just put your email and get subscribed, and immediately we launch, which is around June. That's June 2025 this year at the time of recording this video. June 2025 will be launched. So if you're watching it before then, just put in your email so that we can be notified. And if you're watching it after launch, congratulations. You can just sign up immediately. So yeah, we have our complex chain result. Now let us check the result for that. Let us see what it gets us. But I think let's run through this first, because this probably broke some people's brains already. So the first thing we did is to create a new chain. We want to combine two chains. So we'll create a new chain. So the chain has a prompt also, a prompt template. So we designed the prompt template. We designed it in a way that it gives us the result from the first chain too. It quotes it. Then it then gives us the reason why that fact is correct or not correct. So then we create our checker chain, which is our fact prompt with our model and parser, which we've already defined. Our model stays the same. Our parser stays the same. We also want a string parser, but you can switch models and parsers. You don't have to use the same model and parser, but for this example, it just carries on. Then we create. So now we need the first chain. We need to get the result of the first chain into the next chain. And for the result of the next chain to be plugged, the result of the first chain to be plugged into the next chain, we need to be able to extract this statement from the first chain. So what we did is that we created a runnable parallel, which is a dictionary of key value pairs, where the keys are the keys of the results you want to get out, and the values are the runnables that produce those results. So we make the key statement, which is what we want to get, and pass into this. And we also set it to simple chain, which generates that result. So once we have that, we can then chain our runnable parallel that gets the result of the simple chain to our checker chain, which does the fact checking. Then we use that to create a fact checking chain. So we then pass a topic for our dual chain, our dual chain chain. Then the topic is prompt engineering. We give it to the fact checking chain, and then we get a result. So let's see if the demo gods are on our side and nothing blows up. I'm going to pull this up a little bit so that we can see stuff clearly. Now let us run Python working with Runnables. Python working with Runnables. So enter the functional programming answer, the combined chain answer, the function that was converted to a runnable, and now the other function that does the fact checking. And if you look at this here, complex chain result, it says the statement prompt engineering involves crafting effective input prompts to optimize the performance of AI language models. That's the actual result from the first chain. This quoted statement is the actual result from the first chain. As we instructed it, we told it to quote the statement. So that's the result from the first chain. And it told us it's correct. Awesome. Would the model rat on itself? I don't know. So the reason is that prompt engineering is a critical technique used to elicit the best possible output from AI language, yada, 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 or the reason that makes it correct. Yeah, that's it. We've been able to combine two chains. We're able to combine two chains together. And that's just amazing.